of the power logic. So I hope you guys all had a great AMC season and you guys has achieved the score that you guys desire to have. So I think this problem is pretty interesting from 2023 AMC 10A number 21. And let's go over this. Let P of x be the unique polynomial of minimal degree with the following properties. P of x has the leading coefficient 1. 1 is a root of P of x minus 1. 2 is a root of P of x minus 2. 3 is a root of P of 3x. And 4 is a root of 4P of x. The roots of P of x are integers with no exceptions. The root that is not an integer can be written as m over n, where m and n are relatively prime integers. What is m plus n? So yeah, okay, this one is a pretty interesting problem because we don't know what the degree is. We just know that it's minimal degree. And we also know that P of x has a leading coefficient 1, so it's a monic polynomial. And we also have that 1, 2, 3, and 4 are all roots of a polynomial that's somehow related to P of x. And we want to find the root that is the only root that's not integer. Okay, so let's boil down with all of these things. So first, 1 is a root of P of x minus 1. Okay, then that one doesn't really show us too much. We just know that P of 1 minus 1 is equal to 0. So we know that P of 1 minus 1 is equal to 0. Okay. So what next? P of 2 is a root of P of x minus 2. And we plug in 2, we get P of 0, which is equal to 0. So we also know that P of 0 is equal to 0. Okay. And what about the third one? Well, 3 is a root of P of 3x. Now we plug in and we get P of 9 is equal to 0. So P of 9 is also equal to 0. Now let's take a look at the last one. 4 is a root of 4 times P of x. But we know that when we multiply a constant by a polynomial, if the polynomial like itself is already 0, then we multiply a constant, we still get 0. So therefore, this basically just implies that 4 is a root of 4 times P of x. So basically, P of 4 is also equal to 0. So we have these 4 conditions. So from here, we know that P of 1 is equal to 1, and we also know that 9, 0, and 4 are 3 roots of P of x. So we can let P of x equal to a times now we can let P of x be equal to x times x minus 4 times x minus 9 q of x, which q is just some other polynomial that we don't know. Then we know that P of 1 is equal to 1. So times q of 1 is equal to 1. Which implies that q of 1 is equal to 1 over 24, okay? So what does that tell us? So that basically tells us that q of x is equal to 1 over 24. But we know that we must have one exception, which is that the root that is not an integer can be written as m over n. So if we want this to be minimal, then we must have, therefore, our polynomial, so the minimal degree would be 4. Since if it's 3, then we would have all of them to be integer, and we do not want that. So would be x times x minus 4 times x minus 9 times times x minus r, such that 1 minus r is equal to 1 over 24. Okay. Which implies that r is equal to 23 over 24. So therefore, our answer to this problem is just 23 plus 24, which is 47, which gives us the answer choice D. So thank you guys for watching, and I hope you had a great day, and also I hope that you guys also understand this problem better, and you guys would be able to use this technique for other problems. So basically, a overall summary will be just we first use all of these four conditions to kind of boil down, or giving us some clues of roots of p of x, and then we set the polynomial p of x to be the product of the three binomials times some other polynomials, and we plug in some values to get some clues of the other polynomial that is multiplied by, and then we try to find that. So thank you guys for watching, and hope you had a great day. Bye bye.